What's up, everybody? Hang on, let me just quickly fix the camera. Awesome. Hope you guys are doing well. Hope my microphone isn't giving any issues. Yeah, this video was a little bit, I don't want to say impromptu, but even though the streams are planned, today was really hectic. I didn't even get a chance to make like a nice thumbnail beforehand because I was so busy with work and the baby and all that stuff, but at least we're here. And I thought about, hey, let's just maybe talk about network redundancy, something that a lot of people want in their networks, and maybe you don't fully know how you want to incorporate or set it up. So this stream will kind of just be looking at some forms of redundancy that we can put on the network to try and just make things better so that if there is an event of maybe a link going down or a router going down or something happening, that your network can at least stay up and that you can still deliver a service to your customers. Cool. So first thing I want to do is just start up a new lab on Eve. Let's maybe call this TMB stream redundancy. Save that. And since I love using MikroTik, we'll probably import a few of them quickly. But I want to import the MikroTiks, but then we just quickly want to think about the different forms of redundancy we get. So I might just add 3 MikroTiks for now. We will add some more, but I just want to add a few baseline ones so that we can play around with a few things. I'll add a few more Ethernet ports, even though we really won't use them. I just like having them in case. And let's save that and start up these routers. So we got a MikroTik 1, MikroTik 2, and MikroTik 3. Oh, Clap, the newborn is really good. He's, I don't want to say he's very fussy, but he's still a newborn. So, you know, they are very talkative at that age when they are, or let's say if they're vocal, if there's an issue, like if they maybe wet themselves or they want to eat, they really let you know, even if it's like 2 o'clock in the morning and then again 3 o'clock in the morning. So my sleep pattern has been a little bit changed lately. Let's say it feels like I'm in high school and it's high school holidays and you just want to be up all night. But this time I'm not up all night to play video games or anything. This time I'm up all night to look after a baby with my wife or fiance, and it's really fun. I love it, but it's a different experience. All right, let's see MikroTiks. Let's just connect MikroTik 1 and 2 first, and let's just look at some forms of redundancy. The first thing that I think we should look at for redundancy is something that you'll see a lot, and even though it's used a lot, people don't really pay attention to it much, and that's STP. So let's just connect 2 links between MikroTik 1 and 2, and let's just quickly talk about STP. What is STP? So since these are cloud core routers, each port is currently in its own broadcast domain. So all that we want to do is create a bridge so that we can actually set up STP or emulate it properly. So I'll just quickly add a network. We can leave it as a computer. Maybe call that MGMT. And it will be on my cloud network. Maybe let's just put this in the middle so that when I connect it to MikroTik 3, it's easier. Let's connect Ether 10 to my management network. Ether 10. I might just quickly need to put on a be right back screen. So don't think it's me not liking you guys. I just want to make sure I don't have any details on Winbox. Yeah, all right, we are good. I'm just bringing everything back. All right, there's Winbox. So let's look at our neighbors. We have a couple of MikroTiks, MikroTik 1 and MikroTik 2. I can see which one is which just by looking at the MAC address. So let's connect onto both of them with Winbox. Oh, I need to specify admin blank. So there's MikroTik 1. No, we don't care about that right now. And let's connect onto MikroTik 2. And I'm not really going to do like a deep dive into STP. I just want to talk like kind of what STP does and why it's nice. But I won't say that like this is, you'll use it for redundancy, but you'll probably look at a few other things as well. Okay, so first thing we said is we wanted to just add bridges. So let's just add bridges on both routers and add ether 1 and 2 to those bridges so that we can actually emulate STP quickly. So let's apply that, All right, and let's add our ports quickly. So ether 1 will go to bridge 1 and ether 2 will go to bridge 1 as well. And we'll do the same on router 2, ether 1 bridge 1, and then ether 2 bridge 1. All right, so in theory STP is already running. I just quickly want to get my YouTube screen back. There we go. All right, so in essence what STP does is STP is a protocol that runs that kind of just makes sure that there are not any loops occurring on the network. So if you've ever wondered why when you maybe patch a device into a new switch and that switch takes like a while to actually come up, you know, it like the light comes on, it flashes a bit, then it goes off again, and it like comes back on and does a few things. Like that's actually STP figuring out what's happening on those ports and if there might be any loops or stuff like that happening. And this is really nice to have because if there was a loop, then STP just like stops the port from being able to forward or do anything. But what makes STP viable for a redundancy in our topology or in our solution is we will have two links, and only one of the links will actively be forwarding traffic. It will be sending traffic onto the other router, whereas the other link will kind of just go into a backup state where STP will tell it, hey, the primary link has dropped, so now you need to take over and continue with working. And this is what I just want to show you guys with STP. So I'm not like going to deep dive it because STP is already running. If I go into the bridge and we look at STP, this is already set to RSTP. The R stands for Rapid Spanning Tree Protocol. You do get different versions of it. And this is more or less just to support STP if you maybe have different vendors. Because maybe you have a vendor that doesn't do RSTP, but they do MSTP. Then you can connect with them using MSTP. But it's very rare that stuff like that happens. We've got priorities, but these priorities are more or less to decide which switches are master or slaves, or not masters. Let's say they call it a root bridge. That's the proper word for a switch that is the primary switch where all of the traffic kind of needs to get out or get to. But we've now got two interfaces in a bridge, and all that I want to do is I want to go and do an IP address quickly, and I want to just assign 10.0.0.1/24. But I'm not going to assign it on ether 1 or 2. I'm going to assign this to my bridge. And let's just assign an IP address in that same subnet on router 2. So 10.0.0.2/24 on bridge 1. And then what I want to do is maybe just run a ping. Let's maybe do that from the command line. Looks a bit bigger. So this is MikroTik 1. So from MikroTik 1, I'm going to run a ping to 10.0.0.2. And I'm getting a ping or a response, and that is now to router 2. So here's where the redundancy bit comes in. So I'm just going to run this ping. And let's just go to Winbox. And let's see if the ping keeps running. So I'm on router 2. And then from router 2, what I'm going to do is I'm just going to, I can see the traffic is actually being sent over ether 1 because you can physically see the traffic going there. So let's just kill ether 1, disable that. And my ping still runs. Let's re-enable that. Let's drop ether 2. Ether 2 has been dropped. And my ping just keeps running. And the reason that is because of STP. So STP is allowing one of the ports to effectively become a failover link, so to speak, and it would just like push traffic over the failover if the primary link is seen as being down. But again, STP, this is more of a technology being used on the switching layer. This isn't something you're going to use to set up failover from, let's say, a customer if they want failover for internet. That's not what STP is for. STP is literally just two links, and it allows you to kind of, it's not really bonding. This is, we'll look at bonding as well, but this is just two separate links. One link's in a disabled state and the other link is not, and it just forwards and sends traffic in and out that way. But it's nice to have, you see, because now if one of our uplinks failed between our equipment, it doesn't impact us. We can still work. It's nice, actually. Let's see, does anybody have any questions about STP? Doesn't look like it. So if we're good on that front, then we'll probably look at bonding, which I utilize a bit. I think bonding is really nice because what bonding effectively does is it kind of, I don't want to say fuses your interfaces together, but it lets you take two separate interfaces and they can run in tangent with each other, and these links can then send and receive kind of at the same time. So if you have two 1 gig interfaces, you can kind of bond them, and you're not going to have a 2 gig interface, but you're going to kind of have a let's say a virtual interface that can do 2 gig, which is really nice. And this also has the same principle of STP. If one of the links die, the link just keeps functioning, like the bonding still just works. And we're going to use router 1 and 2 still for that same example because we've already got 2 links. But bonding as well is something you'll more or less do on the switching level. So this you will not be doing to a different ISP's network or something. This is more or less, you have a router and your router connects to maybe your access switches or DMZ switches or something, and you just want to have a little bit more throughput. This is what you can use bonding for. And I think a very common protocol that is used for bonding that a lot of people might be familiar with is called LACP, Link Aggregation Control Protocol. And we will set that up actually just now as well. Although MikroTik is pretty straightforward to just set up this way. I might have to bring in a switch to, well, I don't think I have to do that. Let's just use the two MikroTiks. So let's bring up router 1 and router 2. And I'm just going to remove those ports out of the bridge because we don't need to have the ports in a bridge. We're going to create something else which is similar to a bridge, but it's not a bridge. it's a bond interface. So if I look at my interfaces, I can see there is a bonding, and then from this bonding interface we can just add this, and we can call this whatever we want. We can call it bonding. But if we go into the bonding tab, we have things called slaves. So the slaves are effectively the interfaces that you're putting in a bond into an LACP trunk is probably what people are more familiar with, that will be able to send and receive data at the same time. So let's just put Ether 1 and Ether 2 in the bond. And here we get our different types of modes. So here it's like balance RR, but I've never used any of these modes. This is probably more or less something for MikroTik itself. But 802.3AD, that is the, the triple IE terminology for LACP. So that is an LACP bond. Link monitoring, let's just do that with MII for now. Transmit hash policy. So this I will make layer 2 and 3, just so that it can operate at layer 2 and 3. And I'm not going to change anything else there. Actually, the big thing I did was add interfaces, set the mode for LACP, and set the transmit hash policy, which is for layer 2 and 3. So let's just apply that. And what I'm going to do is just move that IP address to the bonding. And I'm going to do the same for router 2 now. So we'll go into our bonding, add a new bond. And we add Ether 1 and 2. And I'll set it for LACP. and make this layer 2 and 3. And let's move that IP address to the bond. Okay, so now I have a bonding interface, and it still kind of looks like what was happening with the STP when I bridged the interfaces. But what you'll see here now is we have traffic, we've got TX and RX on both interfaces flowing. So it's not just on a single interface, both interfaces work together. So it's not like, again, it's not like there's one connection that can do 2 gigs of traffic. It's each interface can now work at the same time. So if you have a server, you could probably do something like a speed test, but it has to be multi-threaded. And that speed test, if you've got a 2 gig link out to the internet, you could potentially get 2 gig, which is nice. But like I said, this is more or less stuff that you would see going to your server infrastructure or firewalls or whatnot. I wonder if I can maybe do a quick bandwidth test and see. Let's try 10.0.0.1. Let's use UDP. Do a send receive. Let's start that. But my traffic, wow. Okay. We broke something because that's not possible. All right, I've got the world's fastest link in this Eve server. So I was actually expecting this to be capped at 1 meg, and somehow I'm doing way more. Oh, I know what's happening. I'm running a speed test to myself, so that's that's probably why. Let's run a speed test to the actual router. All right, there we go. So here you'll see where it's a bit weird, like the connection is capped at 1 meg. So we can see traffic is on both links, but like the one link is kind of not doing anything. Yeah, email. Exactly. All right, so we can now kind of see that traffic does work on both of the interfaces, and that is what bonding can be used for. So bonding and STP, very useful for our layer 2, for our interfaces. And the nice thing is you can put VLANs on your bonded interface. So I can just, I'm not going to do like the weird VLAN thing. I'm just literally going to go into my interfaces. I can add a VLAN, call it VLAN 100, make the VLAN ID 100, and I can set it to the bonded interface, or the bonding interface. What was that? Couldn't add new interface, could not set MTU. That's weird, because that should work. 1500. Couldn't add new interface, could not set MTU. That doesn't make any sense. Let's just check our interfaces quickly. That looks fine to me, but I know for a fact that should work. Hey Roman, thanks for the tip. Yeah, let's also just quickly change the device names while we're at this, so that I actually know which device is which as well. Even though I should know, left is router 1, right is router 2. So let's just call this router 1, system identity, router 2. I just want to check this VLAN bit here, because I know for a fact you can add VLANs to a bonded interface. Just don't know what it's complaining about there. Could not set MTU. Let's try this quickly from the command line. Interface VLAN add name VLAN 100 interface bonding 1 and VLAN ID 100. Could not set MTU. Why are we getting that? Could not set MTU MikroTik. And this is where Google comes into play. Alright, this is saying that it's complaining that the MTU we're trying to set is larger than the L2 MTU. Let's maybe just make this bonding MTU a bit bigger. Let's maybe make it something like that. See if that Couldn't change interface bonding, could not set MTU. Because I know that this works because I've got this running in an actual production environment. So I'm not sure why it's complaining on this virtual CHR. Let's try here, interface set, interface bonding print, interface bonding set MTU 1524. Alright, so that it doesn't like. And this would be unfortunate because I would really like to just show you guys what happens if you just put some VLANs on there, because it's very straightforward. It's literally just like putting it on an interface. That we can do. Interesting. Alright, so we can set that to 1460. So I wonder if I try and add a VLAN interface now, will it take that? Let's try VLAN 100. Oh, hang on. Actually, let's just set this back to 1500. And let's just, on our VLAN interface, let's just make this MTU smaller, I think. Let's make this like 1472 or something. VLAN 100. Let's just see if that works. Okay, so that it took. But that's kind of not the norm. Let's just add this here as well. But I think this might more or less have to do on my real equipment that's running jumbo frames. But it's fine, it's fine. 1472 VLAN 100. Put that on Ether 1. No, not Ether 1, bonding 1. Or VLAN 1. What am I saying? Yeah, bonding 1. Don't use the service tag. Just apply that. Let's just add a IP address to the VLANs to see if that actually works. Alright, so let's make it 10.0.1.2/24. Add that to VLAN 1. IP address. Add this as 10.0.1.1/24 on VLAN 100 as well. And let's just see, can we ping across ping 10.0.1.2? Okay, we can. So we're able to ping across now. And what I want to do is maybe let's just head into Eve. Or let's run the ping from here, ping 10.0.1.2. And let's just do the same type of test we did earlier. Let's just kill some of the interfaces. So I'll kill Ether 1. And my ping keeps running. Bring Ether 1 back up, kill Ether 2, and that it didn't like, but there it's back up. So there we go. So redundancy works for the layer 2 as well. So VLANs running under our bonded interface is totally fine. All right, so that is basically redundancy now on a link level using STP and bonding. Now we're going to look at something a little bit more fun. I might bring router 3 into the equation now. And I might actually kill these links. Let's just delete these links. Which is funny. And connect management to router 3 as well. So now we're going to look at another form of yes, Emil, I'll definitely try and get to that. I'm not sure if I'll get to that tonight. I'll try, but there's so much forms of redundancy on the equipment. But the next one is quite fun. The next one I also quite like, and that is called VRRP. So what does VRRP do? What does it like? I don't want to say what does it stand for, because it's actually quite obvious what it stands for. It's a virtual redundancy protocol. But what it does is really cool. It allows you to effectively assign an IP address that is live, like the same IP address, on two different pieces of hardware, on two different pieces of equipment. And if something should happen to one of the pieces of equipment, the VRRP kicks in on the other router, and then your layer 3 still stays up. So that's really cool. VRRP works at layer 2, but again, it allows an IP address, a layer 3 concept, to live on different equipment, which is really cool. All right, so MikroTik 2, we're connecting on Ether 1. And we are going to connect to MikroTik 3 from Ether 2 to Ether 1 on MikroTik 3. And for this, we can imagine this management PC is also the internet actually, but we'll fix that just now. What I want to do is just quickly get into MikroTik 3. Admin blank, no. And let's just set this name quickly, system identity set name R3. All right, now we want to think about what do we want to achieve. So with VRRP, like I said, it allows an IP address to live on 2 different pieces of equipment. So we're going to have MikroTik 1 and 3 basically have the same IP address, and router 2 will use that IP address as its gateway to get out to the internet. And we'll see like actually what happens and how VRRP works. So I think this is one of my better videos that I made, I think even in 2019, about how to configure VRRP, but this is now just on the live stream just to demonstrate another form of redundancy that I find works really well. Because what you need to think about as well, what you could do with this, and this is really fascinating, is you could run VRRP on 2 different provider edge routers, and these routers could have an IP address where a BGP peer is being established to, and then should one of your PEs go down, it could fail over to a different PE, and your customer's BGP will still work and everything will just function. That's so freaking cool, man. Anyways, let's actually set up VRRP before I ramble on here. So we've got router 1. So what I'm going to do is on router 1, first things first, we're going to go into our interface, and VRRP is layer 2 again. You can do this on a VLAN. You can assign it on a VLAN. I'm probably just going to kill these bonded interfaces. So let's just delete the VLAN, delete the bond. Do the same on router 2. Delete VLAN, delete bond. And what we're going to do now is we're going to look at our interfaces. So Ether 1 and Ether 2, but it's just Ether. So we're actually not going to worry too much. All right. So let's actually start on router 2 and figure out what we want to achieve. So on router 2, we've got Ether 1, which we can call uplink to, actually, let's just leave it Ether 1 and then uplink to R1. And then Ether 2 is an uplink to router 3, sorry. I forgot to put our underscores there. Uplink to router 3. All right, nice. So what we want to do is we firstly just want to add VRRP, and this we can also do from our interfaces. So here's VRRP, and what we do is we add it, and then you can set which interface are you going to run VRRP on. So I'm going to have a VRRP running on Ether 1. This is actually not what I want to do. I think the topology is actually incorrect. Which is around IPv4 VRF, they say. You need to, I think, Emil, you need to give me the scenario a bit clearer, because I do actually route traffic between VRFs, and I don't really have issues. So what type of issues do you actually experience when you try and, is it when you're route leaking, or is this traffic between 2 different VRFs? So if you route from one VRF to another one, and you're maybe using mangles to get between the stuff, like what isn't working exactly. And this is actually also not going to work. So this topology that I said here isn't going to work. So VRRP again is more or less for physical. So the switch we need to, or MikroTik 2, we need to act as if it is a host. And then what we want to do is we're going to have to connect Ether 10, or not Ether 10, we're going to have to connect MikroTik 1 and 3 together. Yeah, make a topology. Maybe use draw.io. It's free. It's literally better than Visio in my opinion, and you can draw up any topology that you want. Okay, I'm actually going to redo this bit. Let's delete these links quickly, even the ones going to my management. And then I'm just going to bring in a switch quickly. So let's just add a nice little switch. This I'm going to use for a Cisco IOL image. Let's call this a switch. And so there's a nice little switch icon. I'm not going to need too many ports. We can have it as 4 ports. All right, that's nice. So we can start our little switch. All right. Let's connect Ether 1 onto E00. Let's connect this Ether 1 on E01. And let's connect this router now onto Ether 2 of the switch. Reason I'm doing this way is because we are kind of failing over on layer 2. So we've got 2 separate cables there. If I wanted to use the previous topology, then I would have had to do some pretty weird thing with bridges, and we don't really want to do that. All right, so first things first is we want to set up the VRRP, and this will set up on our routers on the remote end now, the things that we're going to be using as the gateway. So I think I'm still connected on router 1. I need to just get onto router 3 quickly. All right, so there's router 1 and 3, which are the devices we're going to set up the VRRP on. So let's go to our VRRP now. And now we know Ether 1 is where we're going to set VRRP on. Our VRID, or this is more or less the VRRP ID, and this needs to match on the equipment that you're going to be running VRRP on. So this could be 10 or 100 or 50 or 99 or whatnot, but you want to make this individual for each, let's say, VRRP that you're going to be running. Now we can set priorities. Now priority is very important. So the device with a higher priority is typically the one that will be chosen as the master, as the primary router. So let's say router 1 will be the primary. So let's just change that priority maybe to 200 because the default is just set to 100. We can add a few other things there like authentication or the version or whatnot, but I'm not going to change anything else here. We're just going to use the stock standard settings. So we set the interface, our VRID, and our priority. So let's apply. And you'll see it's created this VRRP interface, but it's red. And with good reason, because there's nothing that's actually connecting with the VRRP yet. So let's configure VRRP on router 3 as well. So we'll select Ether 1 again. Our VRID was 99, I think. Yes. Our priority will make 100. And we won't change any other settings. We'll apply. And it's still red. It's not doing anything yet. So what we want to do is we first want to make sure that we have IP addresses that can communicate on the routers. So let's add 10.0.0.3/24 on Ether 1 for router 3, and this 10.0.0.1 I'll add on Ether 1 for router 1. So first things first, let's see, can I actually ping 10.0.0.3? Yes, I can. Is my VRRP working yet? No, it's not. Why is it not working yet? Because VRRP, again, makes use of a floating IP address that's going to be live at any given point on both of the routers. So what we're going to do is we're going to add this floating IP to the VRRP interface, and it should be in the same range as what these interfaces communicate at. So what I'm going to do is I'm going to add, and this will add as a /32 address, so 10.0.0.254. I'm just going to throw that on my VRRP interface, and you'll see it's currently red, but in theory that should just go black and then it's active. But we just want to also, there we go, it's gone active. Let's assign the IP address as well on router 3, so 10.0.0.254 on Ether, no Ether, on VRRP. And this one will just stay red actually. So if we look at our interfaces quickly, I can look at the interfaces on the main tab as well. And what you'll notice is there's a VRRP interface now under the Ether 1 interface. And this VRRP, it's either running as RM, which is running and master, or it's in a B state, which is a backup state. So the device that's currently active, that's got the IP address as being live, and what IP address I'm talking about is the 10.0.0.254. That is the device that we can use as our gateway, or a BGP peer, or whatnot. So let's put this to a test quickly. Let's go into our MikroTik 2 and admin blank. So what I'm going to do is IP address print, IP address set interface equals Ether 1. Oh, this now is a different name. Ether 1. 0 IP address print. So let's see, can I ping 10.0.0.1? Yes, I can. Can I ping 10.0.0.3, which is router 3's IP? Yes, I can. Now the question is, can I ping 10.0.0.254? Yes, I can. And that is actually now the IP address of router 1. What I want to do just to show that VRRP is working is let's run this ping. And let's go on to router, well, we're going to have to do this from router 1, since that's currently the primary. So on router 1, all that I'm going to do is I'm going to disable Ether 1. And then we'll see there should be some drops happening. And there it's back up. So if I look at my routers again, there's router 3. Sorry, let's just get back there. Now you'll see that the RM is now running on the router 3 VRRP interface. So this means router 3 has become the router. So let's bring Ether 1 back up, and let's just quickly set up something for like internet access quickly. So might just need to do a NAT rule quickly. IP firewall NAT add chain source out interface Ether 10 action mask. Just going to do the same command on router 3 quickly, because I know both of them is using Ether 10 to get to my network. And let's just add route, IP route add, destination is 0000/0, and the gateway is 192.168.74.2, which is my Eve server. Add that same route there. And the reason I'm doing this is just so that I can kind of emulate backup, or not backup, well, yeah, backup on redundancy to the internet. IP route print. Can I ping 192 You know, I'm really silly. I need to just add an IP address in that range on Ether 10 quickly. So IP address add address equals 192.168.74. Let's make it 90/24 on Ether 10. And I'll make 91 on router 3 quickly. All right, let's see, can I ping out? Yes. So let's go to our router 2 quickly. So from router 2, what we're going to do now is we're going to add a route. So this is me showing you that the redundancy is working. So we're going to add IP route add. We're adding a default route out, but our gateway will be 10.0.0.254, which is the VRRP IP. Now let's run a ping to Google's DNS server. And we can see we're getting a response, very nice, 6.5 ms. And all that we're going to do is go back onto router 1 here. And then we're just going to shut down Ether 1 again. And let's see what happens. And boom, it's back up. So that's awesome. We can now see that our VRRP is now actually taking over the connectivity. So router 3 is working. And this is the nice thing about VRRP is if router 1, it's not even about the link going down. If router 1 crashed, it burned, it broke, somebody went in and hit it with a bat or something happened, it fell out of the cabinet, router 3 could take over the workload, and it would really just help your company or your clients or whatnot just not even realize, like you saw 3 packets drop, that's nothing. Like maybe a client that's really frustrated would make an issue about that, but for the most part that's like really good. That's better than constant packet loss until hours later when you can physically go and change out the equipment. So VRRP, really good protocol to run for redundancy. All right, so that's really the layer 2 protocols that I wanted to cover. What other forms of redundancy do we have? So I might tweak this lab a little bit. So let's delete these links. I don't want to suspend that. So let's look at redundancy more from a routing perspective. I mean, there's different ways that you can achieve redundancy with routing. Namely, you can have like 2 static routes or administrative routes that you've set, but you set the distances higher or lower, and then if the one link goes down, then the other route gets preferred. So that's like static failover. With MikroTik, you also get stuff like recursive lookup. So your routing table is kind of smart. It can do a ping almost against like an IP address, and if it picks and that IP is set to ping over a specific like interface or route out, and then it can pick up, okay, it can no longer ping that recursive route, then it will just kind of like fail all of the routes that you've got set for that destination or for that link, which is really nice, because that's kind of an issue you'll see a lot with static routing is you'll define the backup routes, but maybe your link doesn't actually drop. Like the physical interface kind of needs to drop before the route just shifts, which I'll demonstrate now. So let's just add MikroTik 1 here and add MikroTik 2 as well. Going to my management network, so that's kind of going to my cloud, but this MikroTik 1 will connect to MikroTik 2 as well, so that we can kind of emulate being able to get between 2 different hops. And let's quickly jump into Winbox. Let's connect onto MikroTik 1 the moment I can. Okay, but let's do the setup on MikroTik 2 quickly. So on MikroTik 1, let's go into our address. I might remove that address, and 10.0.0.2/24 I can keep. That's fine. All right. Can I get onto my MikroTik 1? Apparently not. Let's just jump onto it here. IP address print, IP route print. Let's just remove the VRRP quickly. So I might just do an interface VRRP print, interface VRRP remove 0. All right. Actually, the tool that is being used, and it is a emulator, this is called EveNG. So EveNG, it's my preferred emulator. I've used stuff like GNS3, Packet Tracer, Viral, and they all have their pros and cons. So I won't downplay any of the emulators. If you're using an emulator, I'm very happy with that, as long as you're using an emulator to try and figure out some of the stuff. But I've had more consistency with my labs since I've used EveNG as opposed to GNS3, because I found whenever I use GNS3 and there's something like a Windows update, a Windows update, that it completely wrecks like how the VM starts, and then I need to like do a bunch of Googling and figure stuff out, and I kind of got tired of that. So that's why I moved to EveNG, and since then I haven't had issues like that. It's like you boot up the VM, it's there. You work on a web UI, and it had this web UI way before GNS3 even thought about it. So I'm happy with this. Okay, let's get back on topic. Have I deleted my VRRP? Yes. IP address print. I just want to remove this VRRP IP on Ether on 2 and 1. IP address enable 0. Interface print. Is the interface disabled? Oh, now I know why it's not working, because we were troubleshooting, or not trouble, we were emulating to see if VRRP works. So let's just re-enable Ether 1, obviously. So interface enable 0. Address print. All right, so let's just see, can I ping 10.0.0.2? Yes. All right, so what we're going to do is first look at some static routing for failover. So this is very straightforward. What we could have is IP route print, and then we have, there we've already got 2 routes, but that is now the route we got from the HCP. And let's, I might actually remove that DHCP client, IP DHCP client remove 0. IP route print. Okay, let's look at our routes. So we have a route out, a default route out to go to my Eve server. So let's just add another route, IP address, or not IP address, IP route, add destination, also going to be a default route, but our gateway is going to be 10.0.0.2. And now we just need to look at our routing on MikroTik 2 quickly. And I'll just have to add some stuff here as well. IP route print. I think this will have DHCP, but that's fine. I want this to have the DHCP client. IP route remove. Let's remove that second default route that was going to the VRRP IP. And then I just need to add my firewall stuff quickly. IP firewall NAT add chain. This is going to be a source-based NAT. Our out interface is going to be Ether 1, and our action is masquerade. All right, why? Oh, okay, I know why it's doing that, because our Ether 1 has a different name now. So Ether 1 uplink to R1, I think. So let's see, can I ping out? All right. To actually test if the NAT is working, we can just ping out as 10.0.0.2. All right, so that works. All right, so I think we've got everything set up that we want to emulate static-based failover. So let's just quickly do this from the Winbox, and then we'll showcase some stuff from the CLI as well. So let's log on to router 1, which is this MikroTik 1. And if we look at the routing table, we have 2 different routes. Let's just maybe maximize this. I might close all the windows and just open them up again. And let's zoom in a little bit. There we go. That looks nice. So now we can see there are 2 default routes out. And you'll very quickly notice that on MikroTik, this is how it displays. One of the routes is blue. And the reason why it is blue is because that's the route that's currently being seen as backup. It's the failover route. And this is kind of not how I wanted this, because now it's sending the traffic to 10.0.0.2, but it's fine. Let's keep it this way. So what I'm going to do is this other default route, what I'm just going to do is add the distance, make it higher. So let's make that 10. That's pretty standard, what you might see people do for failover. The route again with the lower distance is the one that's always going to be preferred. It is possible, and that is what we I don't know why I'm thinking PCC now, but I'll show you. It has nothing to do with PCC, but here with the gateways you can do a drop down. But essentially it's each connection can go out over one or the other. So this is load balancing in essence, but it's a pretty bad way to load balance as well. But you can do that. You are able to do it. I'm not going to say you're wrong if you do that, but there are some drawbacks if you use that that type of failover. So I get it kind of makes sense if you just have one default route and you specify 2 different gateways. Like this makes sense, but again, this is load balancing. So it's kind of like the traffic will either go out over one or the other, and it's per connection, which causes issues sometimes with which is funny, with banks. So you might have users and they're going to their internet banking and they're like, hey, look at me, I'm going to the internet banking, I'm putting in my details, my account number and PIN, and then when they hit that connect button, the next connection comes in from a different IP address, and then the bank is like, what is this, a hacker? What's happening? We don't want this at all. And then they drop the connection. So that is something you might see if you use this type of dual gateway setup. I don't know why I can't think of the name now, because I know it so well, and yet I'm forgetting it. But sorry, I think it's maybe the lack of sleep, because having a newborn kind of does that. To VLAN ISB going to Eve NG. Nice. All right. So let's see. What we can do now is just to test to see if failover works is we can, let's just close all of these boxes. Close that. I should really learn to close like each session, but I kind of don't. You'll see, even if I'm like working, I'm alt tabbing between tabs and everything. It's actually silly. I don't want to open up PuTTY like that. Let's just go into MikroTik 1, and then what we want to do is just run a continuous ping to 8.8.8.8. No, why am I doing -T? You see how tired I am. I'm acting like this is command prompt, man. Okay, so ping is running. So I'm gonna give you show you that the failover works, because what we can do is we can just turn off this link on Ethernet 2. So we can suspend this link, and then the traffic is still just flowing. I actually expected to see some packet loss. Let's just resume the link, and then what I might do is I might delete the link. I can always just re-add it. All right, so that's just working the whole time. I kind of expected to see, yes, ECMP. There we go, Jean-Pierre. That's that's the name I was looking for. Yes, ECMP does give like like problems, especially with the DNS stuff and banks and whatnot. Okay, let's just delete Ether1 quickly. See, does the stuff just still work? That's what I wanted to see. I was half expecting that. But now we're just getting timeouts. Oh. Of course I'm going to get kicked out of Winbox though, because we was using Ether1 to actually get on IP route print. Let's just look at our routes. So our active route is still going to 10.0.0.2. So if I ping 10.0.0.2, I can't ping it, which is very strange. Let's just reconnect these cables. Let's just reconnect again. I don't know why that sometimes happen with emulation tools as well. Can I ping? There we go. So as long as I can ping 10.0.0.2, then I'm happy. So let's do the ping to 888 again. Let's delete that link to Ether1. Can I still ping 10.0.0.2? That doesn't make any sense to me. That is weird. That is super weird. Because those interfaces don't have anything to do with each other. So I'm considering this more as a issue with the emulator now. Because I've got Ether1, I delete that, and then Ether2 also stops working. Oh. Guys, I'm so sorry. So my issue now is I've actually got 10.0.0.1 bound to the wrong thing. All right. Let's just connect that back to Ether10. And let's move that IP address. Set interface equals Ether2 on 0. That should be better. So 10.0.0.2. Okay, I actually think MikroTik2 was also on the same IP. So let's just quickly fix that up. So if I do IP address print, yeah, we just want to move this IP to Ether2. Interface print. So IP address set interface equals Ether2 on number 0. Can I ping 10.0.0.1? Yes. All right. Now we're good. Now we're perfect. So in theory, if I look at my routes on router 1, 10.0.0.2 is my default route, which is active, and then my Eve, which is the secondary link, is not active. So let's run the continuous ping to Google now. And let's turn off the link to router 2. So we can delete that link. Then we're going to get some timeouts. And that should actually, it's still doing the issue that I actually wanted to showcase to you guys. No, that's wrong. It should be Ether2 to Ether2. So this is technically what happens with a lot of the times with static based failover. If I log on to Winbox, I can actually show you, but this is now more or less because I'm running the emulator, because the emulator by default, if I go to my interfaces, all of the interfaces are always running. You see they've got this R. So technically if you pull out a cable, you know, then the interface will go down, and if the interface goes down, then failover can occur. So we can force the failover simply by disabling Ether2 here. And if I then, there you see the routes have actually switched. So if I re-enable it, look at the routing table. If I disable Ether2, then I can see, because Ether2 is my primary route, it's going to router 2, and then it gets breakout. Yeah, so that is definitely something, Emil, that you can use, and that is also where the recursive routing comes into play as well. But definitely check gateway is good, because if we do a check gateway, it will then ping 10.0.0.2 to establish whether or not the route is actually live. So that is actually a good thing to implement, just to make sure, because then we don't need to like have an issue with this limitation, or not a limitation. It's just all the interfaces are running because it's virtual hardware. But now if we do the same thing, if I just refresh the topology and I run my continuous ping and I delete this interface now, it should technically fail over. I'm fairly sure it should. I don't know why it isn't. Let's just go back here, look at our routing table. It's still trying to get to 10.0.0.2 for some reason. But definitely it shouldn't be able to ping that. Oh, there we go. Okay, that just took a little bit of time to reconverge. I would have expected it to be a little bit quicker. I mean, that's still not too bad. It's what's that, like 20 packets or so? Ah, thanks, Emil. But that still feels kind of long to me. But it's nice to see that it actually works, so that's fine. So we use the check gateway now, so that we don't have to physically come in here and disable the interface. But that's again the big issue that people get when they try and do like static failover, is they'll set up the failover, they'll have the two default routes, but your actual link between your router and your upstream doesn't actually go off, and because the link doesn't actually go off, it can't fail over. And the same goes for let me do it this way. Let's just add a couple of text. So 10.0.0.1 and then 10.0.0.2 is router 2, just to paint the picture clearly. So we set up our like failover statically. We say we've got two default routes to get out to the internet, and that's on router 1. We can see them here. We know the one takes us to router 2 and the other one takes us directly to Eve. So the issue, even with the check gateway, is a lot of the times people get like equipment from their ISP. It might be another router or ONT, sorry. It could be like a modem, but they've got like physical equipment at your site as well, and they tell you, hello Mr. Customer, please connect your router to our router on Ethernet 2, and here's your IP address, and then effectively you're just directly going to their router. But what happens a lot of the time is their actual link goes off here, like in the back end, like in their network, but your connection to their router is still live. Like that IP address doesn't die, that link doesn't go down. So that is also like typically causing issues with your failover. So static failover works, but it has like issues that you need to be prepared, that you need to get around of. The nice thing with static failover, since it's manual in a sense as well, is you can just go into your router and you can just say, okay, I just want to make the other route my preferred. So I could just change the distances myself, and then that is how quick we can failover as well. Nicola, you're getting the flag because you are a member for 2 months, I think, on YouTube. So thanks for that. That means you joined the channel as a member, and you contributed some monetary money to the channel, and that's why you got that flag. So that's pretty cool. Thanks, man. Right, so that actually kind of like wraps up the static failover. Man, there's so much redundancy to talk about. What else can we quickly do? Do we maybe want to play with some OSPF or BGP, or I'm not going to touch RIP though. Like, guys, just for people that maybe use RIP in their networks, it's not something me personally, I haven't used RIP in like I'd say 10 years, and people's always told me RIP is like dead, and I've believed them, and I'm sure there's people that use RIP, but yeah, it's not for me. Repos, I did use, I did actually do VRRP already. So if you just, I think you should be able to scroll back in the video. Else afterwards I can like do some timestamps for the video after the stream ends, and then you could just skip to the timestamps. But VRRP has been done. All right, we can have a look at Emil's example. If you want to post your example in the chat, then we just bring it up on draw.io. RIP is like RIP is a in essence, RIP works with hop counts, and it's very weird. So what RIP tends to do is it calculates how long or how many hops it needs to take to get to a destination, and that's how it like bases off which routes are the best. Rest in peace. That sounds about correct. Like and when I last used RIP was, and this just shows you how long ago it was on Juniper, and it wasn't even SRXs. What were they called? Like net boxes or something very similar. Like it was weird. Like it was when Juniper was trying to make firewalls for the first time, and it was really not nice at all. Repos, you might be stuck with 1 meg because that is a limitation from MikroTik actually, because you're running a trial license on your CHRs. You can upgrade them, but that will cost actual money. But if you pay like for a license, the CHR will work as any normal router. But for labbing, I'd say it's fine how you're, if you're limited by 1 meg, you already know. Thanks, Jean-Pierre. Appreciate it. All right, let's have a look. Still waiting. Check the PDF. It's basic thing. Where's the PDF? I'm not seeing a PDF if you posted a link, Emil. But it could be that YouTube also doesn't like links. No, I actually think it's YouTube that might block that, because I've seen the chat sometimes get filtered out if you link things. I don't know. Can I link my own Discord on the chat? Because if we can do that, then you might be able to just go into my Discord and post the link in there. Let's just do an invite. Okay, let's do that. So I don't know if you guys see the Discord link that I sent. I don't even see a thing with like space or anything, Emil. Let me show you guys. But I'm 100% certain this is YouTube that is filtering things out. Like I see nothing. So if I can see your topology, then we can implement it in here and maybe try and figure some stuff out. Let's just delete these links so long. Not sure if you guys heard my baby boy there, but he's a fighter. Well, I see Roman joined, so I think my Discord link went through. Oh, Emil, there you are on Discord as well. So maybe just you can just throw that on the general chat, or DM the moderator Lolox, and because that is my gaming like thing, my gaming account. I am from the good states of South Africa, so I'm down south at the very tip of Africa, but it's very nice here. Warm, but now it's winter, so it's a bit coolish, but it's the temperature's nice, people are nice. I mean, it's got some issues, but I think all countries have issues. I love the country though, it's really nice here. Sorry about the baby again. But it's a baby, they kind of just do that. But his mom is with him, so at least she's helping check, which is actually making me feel a little bit bad that I'm did you put it on the Discord? Let me just go into my own Discord. Discord. Open Discord in my browser. No, I'm not seeing it. Emil, just drop it in the general chat, I think, in Discord. The URL, then I should be able to see that. Because right now, this is all that I'm getting. But I can wait a bit. Oh, even on the Discord server. What about if you try and directly, let me try and message you first. Emil, let's just say hello. Give me the link, please. There we go. Let's see if you can actually DM me then. Maybe I'll just add you as a friend as well. Might help a bit. Maybe if people are interested in seeing some QoS labs, we can play around with that. I know I've made a video on simple queues, and I think I even promised I'd make a more advanced QoS video, but I never got around to it. Which I feel bad about now, because I saw a comment where somebody was like, hey, you said you were going to make one. So that might be a promise to keep with the next stream somewhere, just to actually do stuff like the, you know, we set like tags almost for the queues, or the packets, like are they a 1, are they gold, are they plat, are they what are they? It is really hard to send links these days because people get, like, I don't know if they get spammed. Alright, let's look at your topology quickly. Can I just drag? Oh, because that's Chrome. Okay. Alright, so you're using GRE interface there. That looks good. So we can definitely quickly try and set this up in the lab. These are just going to be like, let's say 4 routers that we set up. I'm trying to still think what issues you have when you... Alright, let's just leave that out of the equation quickly. Let's just add another MikroTik quickly. Stop that, delete the switch. One more micro. Let's just run 648. 12 ports. Okay, so let's do micro 1, micro 2. Actually, let's put 1 and 2 this way. 3 and 4 this way. Oh, so you are running VRRP as well. Okay, that's quite nice. Just assign these addresses quickly, duplicate. But the only unfun thing is in the lab, it doesn't take into account like all of the other backend stuff that you might have running on your own network as well. 0, 2. Yeah, dot 1 is your VRRP. That's perfect. 10, 1, 1, 3 / 24. Two, 3 / 24. 10, 1, 2, 2 / 24. Let's just start that one up. Just throw this ether 1, ether 1. Ether 2, ether 2. Repos, you're welcome to send questions on the Discord, but whether or not I answer all of them, like I don't want to say I'm not going to answer you, but it depends on the type of questions. So if it's something that I can feel like I can help out with or point in the right direction, I'll definitely answer. But if it's like, hello, I am a wireless ISP. How do I fix this? You know, like I'm not like a consultant, so I don't really want to tell people how to run their own networks, because one, I'm not like being supported by that, but also if you have issues because of what I told you to do on your core network, then I don't also want that to come and be my problem then. So I feel like if you need to get a consultant, then definitely reach out to one and they can help you. But I don't like offer consulting services in Discord to try and help people that way. I just want to bring up your PDF here. That looks fine to me. So in essence, you have what, like 2 data centers and they're running different ranges, and you want, I don't want to say, but they're in the same VRF. So do they just need to be able to communicate with each other, Emil? let's maybe just add a, I don't know if I want to add a, yeah, we're gonna have to add some switches. That's fine. Let's add 2 switches just to kind of replicate more or less what you've got here. And I'm gonna add 2 more MikroTiks, but these MikroTiks you can think of are just machines. They're not actually gonna be set up for any routing or anything. I might just even change their icon to be a machine. So this can just be a server. I think there's there we go. There's a Kali. That's better. My kid's so busy. All right. Ten 1 1 10 / 24. Ten 1 2. Let's connect this onto the switch. And then connect to our micros. And you said you've got this as VRF 1000. So we can just do this VRF 1000. Okay, but that should all be the same. So I'm not quite checking my chat either. Let's just have a look here. I have made an IPsec VPN tutorial before, and it is on the channel, so you're just gonna have to take a look at it. But personally, I don't really like IPsec on MikroTik that much. I'm not gonna say you can't do it. It's just a little bit weird how you set it up. But it works. So repos, I recently made a stream where I set up VLAN tagging on CHR, and it made me look like a bit of a fool because I was learning things as I went with MikroTik, because I've never actually done any type of switching on MikroTik. But yes, you can lab VLAN tagging on a MikroTik CHR. So I think the live stream was labeled like VLANs on Router OS or something. So you can also find that on the channel. Like the first hour was just me figuring out what to do with the tagging. So I can suggest watching that, because then you can kind of see my struggles and then also just learn from them as well. Okay, so this kind of looks like your setup, but now we just need to actually set up the links. I just need to get onto your document. Okay, but you've got this set as a GRE interface. So how are your routers? Oh, okay, I get what you're doing. So in essence, you're probably just connecting on IGP with the VRRP IP from both sides. Okay, that makes sense actually. So what we can do is, and you're probably bridging your two interfaces. Am I right, Emil? Although I asked the question, but I know it's going to take some time to get to you. All right. So let's just quickly set up the IPs and such on here. IP address print, IP address remove 0, IP address remove 1, add address 10.1.1.2/24 interface that we want to put on the bridge actually. So let's just add a bridge, interface bridge add name bridge R1 interface port interface bridge port add port interface. I've set this as Ether 3 and 2. Okay. Ether 3 and 2. Oh, do you have a switch between your... Because I'm just checking the this link between the two routers there, but I'm sure I could just use this in a bridge to kind of emulate the same thing. Let's just try interface bridge port add interface Ether 3 bridge equals bridge R1 and Ether 2, and let's just add that IP address, which was 10.1.1.2/24 on bridge 1. Okay, and then what we want to do is just add the VRRP quickly. So interface VRRP add name VRRP R1 interface equals bridge 1 priority. I'm going to assume the R1s are your primary, so let's just set that priority as 200. And our VRID, I can make something like 99. Interface bridge, interface print. And let's just add the IP address, add address 10.1.1.1 on VRRP. Okay. Let's just do the same on the other router. I'm just going to go back into the chat. All right. Let's just add config for router 2 quickly. IP address print, IP address remove 0 and 1. Interface print, interface set name Ether 1 for 0 and Ether 2 for 1. Interface bridge add name bridge R2. Interface bridge ports add. Our interfaces will now just be Ether 3 and 2 again, so Ether 3. Oh, I don't even need to do the bridging. Sorry, Emil, I just saw your message now. I just quickly want to test anyways to see if the bridging works, but we can remove them then. Ether 3 bridge R2 and Ether 2. The reason I'm adding this is I've seen people like do VRRP with a bridge between the MikroTiks like this. It's kind of like what the HA script does for the MikroTik, but I don't like it when you're bridging directly like this. Okay, let's just add our IP address quickly. So 10.113/24. That's wrong. IP address add address 10.113/24 interface bridge. And then did I add the VRRP? I don't think so. Interface VRRP add. Oh, sorry, I'm doing this from the command line now because it's just quicker, and I'll need to connect everything to that management network to use the Winbox. Interface VRRP add name VRRP R2. Interface will be our bridge. Our VRID is 99. And our priority, we can make it 101 just so it looks different. Alright, so let's just see IP address print. IP address add address 10.111. And that goes on to our VRRP. Okay. So I think now our VRRP should be live at least. IP address print, it is live. So 10.111. Okay. I just quickly want to disable the bridge. So interface disable 12. And then I just want to see if router 2 goes live. So this is also us doing VRRP again for you repos, since we are doing it again. Okay, so it is live on router 2 now. Let's just re-enable that. I just want to see if that actually goes off. Because if this is live on both, there we go. Okay, so it went off. Okay, so the VRRP is working correctly. All right, so that's one side of the network, and we haven't done the BGP part yet, but we will get there. Don't you guys worry. Okay, so let's do the other side quickly. So what we want is it's called router 3 now, but that's fine. Let me just open up your diagram. Okay, so what we're going to do is interface. I don't think I'm going to add the bridges now since they're connected to that switch now. So this shouldn't have to be a requirement. Actually, I might add it anyways. Interface bridge add name bridge R1. I'll leave it as that, even though it says R3. Let's add it. Interface bridge port add interface, what is that, ether 2 and 3 again. Ether 2, and the bridge is bridge R3. Okay. IP address add address 10.122/24. That'll go on our bridge. R3. IP address print. Might actually just remove a bit of IPs here. IP address remove 0, 1, 2. Just see, okay. IP address looks good. So IP address. Actually, we need to just add the VRRP quickly. Interface. VRRP add. Interface is bridge R3. Priority is 200. We can make our VRID. Since it's different equipment, we can just make this 99 as well. Anything else I want to add here? VRID priority interface. We can make a name. VRRP R1. And let's just add the VRRP IP address add address 10.1.2.1/20. No. Address 10.1.2.1. That goes on our VRRP. Okay. Do the same on this last MikroTik. No. IP. Let's just set the name system. System set name. No. System. Identity set name R4. Okay, let's just go router. No. Interface bridge add name bridge R4. Interface bridge port add interface ether 2 and 3. Ether 2, and our bridge is bridge R4. And let's add the IP address. Address is 10.1.2.3/24. Address. And our interface is the bridge. And we are going to add the VRRP quickly. So interface VRRP add name VRRP R4. Priority 101 VRID. I think we made it 99 still. And then our interface is the bridge. Alright. So in theory our VRRP is set up now. So I should be able to I haven't added the VRRP IP on this router yet. So let's just do that. IP address add address 10.1.2.1 interface VRRP. So the VRRP side is done. Let's just quickly assign this on the MikroTiks as well. Well, on this client computer, which is not really one, but I want you to think it is one. IP address add address 10.1.1.10 on ether 1. Can I ping 10.1.1.1? Okay. So the VRRP is working from this left side network. Now we actually need to connect the BGP first. Hang on, where's my chat? Okay, I first need to figure out how is your BGP connecting, because you've got your routers in different networks here. So they aren't shown as yeah, I'll add the default route. Thanks, Emil. So let's just add that IP route add destination 000/0, and then the gateway will be 10.1.1.1. So Thomas, for you, the VRRP IP is typically a /32 address. So the IP address that you bind to the VRRP interface is a /32, but that IP is going to fall under your /24 or /29 or whatever addressing you're using on the actual interface that the VRRP falls under, if that makes sense. It's just so that the VRRP doesn't like cause some IP addressing issue. So I think it's more like a broadcast thing, because it only typically needs to be a single IP. Okay. But now my issue is we're getting to router 1, but your BGP, how do you have this configured between, let's say, this MikroTik 1 and MikroTik 3? So let's just look at your document. Let's bring this up to the screen. So here you've got your site A with your AS10. Can I just assign whatever IP I want between these two routers? I might just give it like some /30 just to get the routers able to communicate with each other directly for the IGP. Because in theory, it doesn't matter if you've got like a GRE tunnel or something, just as long as the BGP is forming a peer, forming a relationship, and it can pass stuff. Yeah, so let me just connect like a link between the routers on Ether 1. And I might make this something like 10. Let's make it .100, .0, .0. Make it a /30. The /30 is nice and easy to remember because then you know definitely which side is which. Unless you're using like point-to-point tunneling, but we're not going to do that. All right, there's a nice little /30. So the left side, I'll make the .1s. The right side, I'll make the .2s. So let's quickly just assign those IPs as well. Let's go into this MikroTik. I'm doing that thing with the tabs again. So IP address, add address 10.100.01/30 interface ether 1. Let's close the tabs after. Why have I didn't even realize I stopped listening to music. Sorry if it looks like I'm confused. I'm just trying to skip past some YouTube ads to actually get music on. Because I don't know, I feel like I work a lot better if there's music involved. I feel like a lot of engineers feel the same. Okay, IP address print, IP address add address 10.100.02/30 ether 1. Can I ping across? Yeah. Okay, just assign here on the other micros quickly. IP address add address 10.100.1/30 interface ether 1. IP address add address 10.100.12/30 ether 1. Can I ping across 1? Okay, so that looks fine. This would also actually be a nice place to have some VRRP running for this as well, but it's all good. Okay, let's quickly do the BGP config. Let's maybe drag this management PC in here so that I can just configure it on Winbox and CLI quickly. There we go, that looks fine. Okay, let's start with router 1. Refresh it, that should be router 1. That's router 3. Okay, we're good there, connect. Okay, so first things first, let's just set up our BGP. Let's set up an instance. We can set this instance as AS10. I think you had the example as. Our AS is 10 there. I might set the router ID. Let's just make it whatever the VRRP IP is. Well, not the VRRP IP. Let's make it 10.112. It should be fine. Okay, but you are using VRF, so let's just call this, what's the VRF that you made it there? VRF 1000. Let's just call this VRF 1000. And let's just add the VRF 1000 quickly. So we've got a VRF 1000. I'll add the other bits just now, but let's just do the route distinguisher quickly. Import, export routes, apply that stuff. And put that on the other screen again. I actually want to add the bridge and the VRRP IP to the interfaces. There we go. So that's R1. Let's just jump onto R2 as well, or R3 in this case. Connect. That's not ROM1. We don't want to get on onto ROM1. Okay, so IP routes. VRF. That was VRF 1000. Our interfaces will be bridge R3 and the VRRP interface. Route distinguisher 1:1000. Okay, so we've got the VRF bit sorted. Let me just check anything on the chat. Oh, AS10 is the main table. All right, we can play with that just now. What I just want to do is set this for now. I've got a suspicion about something. Okay. Okay. We've got the BGP instance on router 1. Let's just add the instance on router 3 quickly. Because I get what you're doing. You've just got AS10 on your main routing table. And I will test that just now as well, but I want to span the service this way that I know or that I feel works. So AS10 router ID is, where's your drawing? There we go. Ten, 1, 2, 2. Okay. Okay, so first thing we want to do is create the peers. So peer 2 R3, peer 2 R1, set our instance. Remote address 10 100 02 10 100 01. Our AS is 10 because we're using IGP. I'm not going to set anything there. I won't set any of these other details, but we will go into the advanced and just quickly set this for VRF. Let's just set our update sources as well. So this was Ether1 in both cases. And that looks fine to me. All right. Now let's just add the VRF bits here. So I'm using AS10. But I'm using this VRF 1000 routing mark. And I'm just going to redistribute my connected routes. Oh. Hang on. Did I set that instance? Routing mark AS. Couldn't add new BGP VRF. Can have. Okay, wait, let's use the default instance. No, but I'm not connecting with the default instance. Hang on. Where's my peers? Oh, I haven't even connected the peers yet. No, but I had it open here. Did I close the box somewhere? No? Oh, I know what I'm doing wrong there as well. Okay. Ugh, I'm being so freaking silly now. This instance is fine, but we're going to keep this in the main routing table. Definitely a long day. Just remove that out of that VRF 1000. Then we'll just add the VRFs here. We'll use the AS 100, but we'll use the VRF 1000 routing mark, and we'll redistribute the connected. That should take, there we go. So AS 10, but the routing mark is VRF 1000. My peers should connect. There we go. That's established already. Routing BGP. How is that established? Session, close all windows, routing BGP. There's my peer now. Okay, that's perfect. Alright, we can turn on route reflect as well. Let's apply that. And it establishes. What we want to have a look at is our VPN4 routes. Okay, the VPN4 routes are there. They are being learned. And that looks okay to me. I'm learning both routes. If I look at my routing table, I'm learning it through the BGP. And the distance 200, that's right, if it is IGP. So I think what I just want to do is quickly get onto this other client MikroTik. Admin blank, no. IP address, add address, and this was what? 10.1.2.10, I think. 10.1.2.10/24 on ether 1. IP route add destination 0000/0. Gateway 10.1.2.1. So let's just first see, can I ping something like, was it 10.1.1.2? Alright, so I can ping across there. And I can ping across. So I can get between the two hosts on the network, which seems good to me, seems okay. Let's just stop that. I just want to do the setup as well on our bottom routers so that we've got that little bit of a redundancy. So let's just do IP. No, we're not doing an IP. No, we are doing it. Have I added that IP? Okay, I have added the, let's say, BGP IP. So what we're going to do is firstly routing BGP instance add name AS10 router ID 10.1.1.3. Okay, routing BGP peer add name peer to R4. Remote AS is 10.100.1.2. No, that's not the AS, that's 10. Remote address 10.100.1.2. Update source is ether 1. Address family is no, not L2 VPN. VPN v4. And I feel like I'm missing something. We've got AS, we've got address, we've got source, we've got address family. Routing, BGP peer, status. Okay, that looks fine. Wait, our instance is wrong. So let's just quickly set that. Routing BGP peer set instance AS10. All right, I'm happy with that now. Let's just quickly go into the router 4 MikroTik. There's still something I need to add, but I'll add it just now on the other router. Routing BGP instance. Wait, let's just look at the IPs. IP address print. Routing BGP instance. Add a name AS10. AS10. Router ID. 10 1 2 3. Then we can do routing BGP peer add peer name peer to R2. This time we'll set the instance remote AS10 remote address 10.100.1.1 and our update source is Ether1 and our address families is VPN 4. Routing BGP peer. Let's just print. Let's just see it is established. Our peer is up and running. All right, but now the bit that I forgot to add, let's just add that quickly. Is my VRF added though? Let's just check IP route print. IP route VRF print. No. So let's just add that quickly. IP route VRF add routing mark will be VRF 1000. Our route distinguisher is 1/1000. That's okay, Emil. I'll take a look on the Discord message now as well. Let me just open it up on a different screen. I see. Export, route, import. Let's just add the interfaces. That is the bridge and wonder, can I add it this way? Let's try VRRP. VRF print. All right, that's good. So what we want to do is routing BGP instance VRF add. Our instance is the AS10 and our routing mark is the VRF 1000 and we will redistribute our connected routes. Okay, let's do the same on router 4 quickly. Routing BGP. Now, first the VRF IP route. VRF print IP route VRF add. Routing mark This equals VRF1000. Our route distinguisher is that. Our import is that. And our export is the same. That looks fine. Oh, let's just add our interfaces as well, which is bridge and our VRRP. Okay. And now we just want to go into our routing, BGP instance, VRF, add instance AS10, routing mark, VRF 1000, and let's redistribute connected, yes. So if I do an IP route print, IP route print where routing mark equals VRF 1000, I am learning the correct routes. Okay, I'm quite happy with that as well. So what I want to see is if I ping from this host 10.1.2.10 to 10, wait, I want to ping 10.1.1.10, which is the opposite side at this MikroTik. In theory, what should happen is it should come to the switch, it should go to MikroTik 3, which is the primary VRRP IP, and then it should be passed over this BGP. Well, this route is learning through this BGP session between MikroTik 1 and 3, and then it gets to this MikroTik 7. So I'm just going to stop MikroTik 1 completely, and let's just see what happens. Because in theory, if I stop that MikroTik, the VRRP should be switching to MikroTik 2. And we should have access this way. Something I just want to check. Can I ping .3? No. Okay. I'm just quickly going to get this router back up, because in theory I should be able to get to .3. But I'm wondering, because the traffic's going to alright. I think I may need to set up something between the site routers. Not necessarily BGP, but that can definitely help. Because what is happening now is we've got the MikroTik, it's sending its traffic to MikroTik 3 still, which is correct. And the MikroTik 3 doesn't know about this tunnel that's still up between, well, I'm calling it a tunnel, but it's not a tunnel. But that MikroTik 4 still knows how to get to everything. Oh, so are you using BGP between these MikroTiks as well? Well, if that's the case, it should make it a lot like simpler. So let's just duplicate some IPs, but I'm gonna remove Ether2 out of the bridge then, which is good. So let's just remove Ether2 out of the bridge. And give this its own new IP. So this we can make 2. And this we can make 3. So I'll make the top ones .1 and the bottom ones .2. So let's just quickly action this. Connect onto router 1 and 3 quickly. So then what we're going to do is we're going to go to our bridges. We're just removing Ether2. We can still keep it in a bridge, like that's not going to impact anything like here. Sorry, I'm just getting some message. Okay, it's fine, don't worry. Alright, so let's just quickly remove Ether2 from the bridge on the bottom router. So interface bridge port. Interface bridge port remove 1. And we're going to do this. Okay, wait. While I'm here, IP address add address 10.102.2/30 on Ether2. And we're going to add the same type of setup now on router 4. So interface bridge port print interface bridge remove 0. IP address add address 10.103.2/30 on Ether2. Okay, so this is just us getting the IP addresses assigned on the Ether2s now. So 10.103.1/30 on Ether2. And let's do a ping to 10.103.1.2. Alright, that looks good. So let's just add the IP on here, 10.102.1/30 Ether2. Oh, no, I'm pretty sure I removed the port. Let's just check IP. Let's go back to this MikroTik. So this is the interface bridge port, and I removed basically Ether2, which was this item, out of the thing. All right, cool. So now we've got, I don't want to go to IPv6. Now we've got connectivity directly between our site routers. So we can effectively just quickly set up some BGP with them as well. I don't need to set anything with the AS. All that I'm going to do is I'm going to peer with 10. There we go. So we can make this peer to R2. Instance stays AS100. IP is 10.100. 2.2. AS is still 10. I'm not going to set anything else here. I'm going to go into my address families, VPN 4, set my update sources Ether2, and apply this. Oh, we want to set the root reflect as well. And let's just do the same thing on the right side. This is going to be a little bit quicker since we've already set our ASs and the VRFs and all that stuff. Peer to R4. Instance AS10. Address 10.103.2. Remote AS10. Nothing else here. We're going to go into our advanced. Allow VPN 4. Put that on Ether2. And this isn't going to establish it because we still need to configure it actually on the bottom routers. So let's do that. So routing BGP peer add name peer to R1 remote AS10 remote address 10.100.2.1 instance AS10, and our update source is Ether2 and address family VPN 4. And I might just copy this like this and just rename a little bit of stuff. This is going to go to 3.1 and this will peer to R3. So if I do a routing BGP advertisements, I think actually I need to do VPN 4 route print. All right, nice. Can I print this as detail? Yes. So I'm learning my 4 routes. I just want to see what I'm learning exactly. Okay. That looks good. Let's just see what this looks like from Winbox. Still not totally happy actually. Feels like I might be missing something. Just look at the actual routing table. Okay, that looks fine. Oh, I want to redistribute my other BGP routes on the VRF bit here. Let's just quickly add this. And I might have to do it here as well. Routing BGP instance VRF print instance VRF set redistribute other BGP yes. Close here. Open the other one. And let's check here. So routing BGP, not advertisements. This is L VPN v4 route print. Routing BGP instance. Just want to have a look here. That looks fine. But I feel like it's not doing what we wanted to do yet. And we can check this by running that test again. Oof. Let me just quickly close these windows again. Oh, come on. Okay. So I just want to jump onto that router on the right hand side and run a ping again. So we're just gonna ping to 10.1.1.10. And then what we want to do is effectively stop that MikroTik. Yeah, it's still not doing what we want. Traffic is still going to router 3. Let's just see 10.1.1. Oh, but we need to wait a bit. We need to wait a bit. But I don't see second routes though. But we need to wait for the BGP to like stop. Which also takes 30 seconds unless we configure a few extra stuff like different hold timer. I know what we can do just to make this a bit quicker. And this is going to be annoying because I'm going to have to turn that router back on again. But let's just quickly enable BFD between those two routers, or those peers at least. But it's going to be quick because it's on Winbox. It's just a matter of going into my peer and setting BFD. Peer to R3. Use the BFD. Apply. Okay. So I just want to have a look and see what happens with the routes when I remove. Can I ping .2? Can I ping .3? So that is an issue for me, that I can't get to .3. Okay. Let's stop this and see what happens. But the BGP, yeah, it's already killed itself. So if I look at my routing table, I'm not learning those routes. I might quickly just want to bring, let's do this. This will look a bit nicer. So Ether 10, Ether 10. So specifically when I have a look at router 4 quickly. Router 4, admin blank. Why is that unknown? That's not good. That should be going to Ether 3. I did remove the bridge on here. I don't see how, but all right. Let's just quickly re-add the bridge. Bridge R4. Let's apply that. Check our ports, set the bridge. Well, Ether 2 I'm not putting in a bridge. And then Ether 3 can be in the bridge, that's fine. Let's just move that IP address to the bridge quickly. So that's back. Yeah. All right, but that's not why this other bit isn't working. Well, maybe it is. Let's just see, is our BGP connected? It is connected. So VPN 4 out. Or VRS, this is fine. Because in theory, what should happen is this MikroTik 2 should advertise those routes to MikroTik 4, which it is doing. There we go. So I'm learning 10.1.1.0/24 over this Ether 1 interface. And what should happen is I should learn the same routes on router 3. But I'm just learning routes for 10.1.2.0/24, which is not exactly what we want. And the config looks okay because we are telling this to redistribute other BGP routes. So any BGP routes that we learn, we want to also send out. Okay, that looks fine. Maybe I'll just put on this IP bit as well, but I don't think that would cause an issue. So we are actually just going to check some stuff between router 2 and 4 as well. Yeah, that's a good point, Gonzala. That's also true, Emil. I actually think Emil is hitting the nail on the head. Let's just set this stuff up. Because I'm fairly sure I didn't set the route reflect. And that might also be an issue, to be honest. Let's just set the stuff. Where's my router 4? There you go. Okay. Okay. That looks better. Although although the interface it's learning it from is unknown, which is interesting. 113. Can I get there? No. I still can't get there from here. Let's just look at something for the BGP with the shouldn't be this. That's fine. That's also on, so that's also good. So there it wants to use 10.100.1.1. But it won't be able to get there because, oh man, this is actually... We can restart the routers, but I think... Okay, let's see on router 3, you say. So let's just look at our peers, BGP peer. Oh, that route reflect, thank you. That might actually also have a bit of an impact. So let's just look, our VPN 4 routes still aren't... since it is IGP, yeah, this is a conundrum because I can kind of see what the issue is. So router 3 is now learning the routes, which is fine, it's good. Oh, hang on, let me just first see. Hang on, let me just do a be right back screen. Just make sure nobody sees anything. Yeah. I think I get what you meant. Sorry, you guys can't see, but I see the issue as well. So what's happening is we are learning the routes over the path that it needs to get to. But our issue now is router 3, the IPv4 route or the VPN4 route. So the VRF route that it's learning, it's getting the route, but it's putting the gateway as 10.100.1.1, and it doesn't know what that gateway is. That's why we're getting this interface unknown error as well, because 10.100.1.1 is the link between router 2 and router 4, but it's now trying to use 10.100.1.1 as a gateway, and it doesn't know about it. So this is now the conundrum or the issue that we're having. So I can see your issue, Emil, and I think I understand why the the guys from MikroTik feel or say that Router OS version 7 should solve that. But there has to be some way to make this work. I feel like we need to be able to make this work. I can't accept that's the end. Wait for version 7 to release, because that might be really, really long. Let's quickly restart the routers. We can do that. But typically the issues that I see with whenever I restart like equipment, it's more or less because I can see an issue, and in this case it looks like a it might be fixed in the next video if I fiddle around with this. So Emil, we can definitely have a chat, but I think I might call the stream now, and if you don't mind, we can either talk about it tomorrow or maybe even continue it with the next stream. But we can definitely have a chat. That's 100% Emil. Like the loopback addresses on OSPF, that's something that I also tend to use, and then you would connect with BGP to those loopback addresses. I think that's essentially what we did in one of our bigger lab streams, where all of these routers in this network, let me just zoom out a bit, they all have their own loopback address that is being advertised via the OSPF, and the OSPF is working as the IGP, and we are just like forming peers using the loopback addresses. So I don't know if this is more or less like a type of setup that you're familiar with, but I would actually like to have a call with you as well and figure it out, but not right now. Right now I'm actually thinking I want to head off to bed and make sure that everything is still fine with my baby and fiance and stuff. So I feel like sorry that we couldn't fix the thing that you brought up on your redundancy, even though it's a nice idea. I get what you're trying to achieve here. I mean, this is actually really cool, but I can also see why like it's not working right now. Let's just quickly see if it is working, but I really doubt it. If I just want to get onto router 3. It's not there now. Let's just find it in the neighbors list, because these unknowns is the issue for us. And I know if I stop that, yeah, it's still an issue. Yeah, look, but I would like to figure this out still, so I'm actually going to put some more time into seeing what we can do. But if it's not doable up until version 7, I mean, that sucks, but I feel like there must be some way to make this work, even if we need to put in like an extra bit of equipment or do something strange, you know. Like that's always a thing on MikroTik, but I get what's happening. Since this is IGP, it's causing some issues. Anyways, guys, I am gonna cut off the stream here. Thanks again for watching. I'll be live again next week, definitely. And I see a few of you joined the Discord server. Please feel free to use it to ask questions. I'm happy with asking questions and figuring things out like we did now. It's just, again, I don't want to like be a consultant to tell you how to fix your you know like it's like especially when it comes to radio frequency stuff, guys. I'm terrible at radio frequency. I'm really bad at radio frequency. The moment you speak radio frequency, I'm lost already. Like I use like Ubiquity's alignment tool to figure stuff out like that. Anyways, guys, I'll catch you in the next stream. Have a great evening and peace out. Bye bye.